Hi friends, welcome to WebChamp. In this video, I am going to discuss about the acid properties of database. So let's say you are working with the database which is going to store the transactional data or business related data. We can say the bank transactions data or sales purchase order data or sales data. So any kind of transaction could be there, but that system should be strong enough to ensure that the reliability and integrity of the transaction. What does mean by reliability, right? So if you just look at the definition, you will not understand anything. Now let's discuss a reliability meaning. So reliability refers to the ability of system to function correctly and consistently over the time without failure, right? So in the context of database, meaning the RDBMS, where we are going to save the data or where the transactions are saved, maintained, that should be reliable to ensure the data remains accurate. It should be available and consistent despite the system crashes or power failure or software errors. Meaning, in any situation, your data should be safe. And to ensure that, this acid properties comes into picture. So first acid property, A stands for atomicity. So it will maintain the data that is like all the cells are filled with only one value. We can say that to ensure that a transaction is all or nothing. If any part of transaction fails, the entire transaction will be rolled back. Meaning, if someone initiated the transaction, the money has been debited, but money is not credited to the next or third party person's account. In that case, your transaction is not completed. So entire transaction should be rolled back, and the money from whose account is debited, that should be returned, right? So this comes under the atomicity. Then what does mean by consistency? The consistency ensures the database transitions from one valid state to another. So if we discuss the example of consistency, so banking system, most of the times, okay, banking system should never show a negative account balance due to system error. Okay, because of system error, the system should not show negative balance of any account. So this is what we can consider as a valid state or valid data at all the times. So data integrity rules like constraints and triggers must always be maintained to make sure the data is valid in that column, right? Then next is isolation. It ensures the concurrent transactions do not interfere with each other, meaning there are two persons. Let's say one, they are withdrawing the money from the same account at the same time. Then the balance of the account should be calculated properly. It should not overlap and show the incorrect balance. So for that purpose, each transaction is isolated, meaning that one until the one transaction gets finished, another transaction will not be processed. And transaction result remains independent until they are committed. Right. So meaning first transaction gets completed, then the balance will be updated, and again then second transaction will get completed. So this is how, meaning simultaneous transactions cannot be processed. It will be isolated. Next is durability. So it ensures the transaction is committed, meaning once the transaction is committed, it remains permanent. Even in case of system crashes, transaction should not be lost. Data is stored in non-volatile memory, example hard disk or SSD, whatever will be the storage system there. In case of, let's say, in the middle of power failure occurs after a transaction is committed, the changes remain intact when the system restarts. These properties makes relational database management system reliable for financial transaction, or for the enterprise applications, or for the critical data storage. This is nothing but ACID properties: atomicity, consistency, isolation, and durability. So I hope you got the idea about what is ACID and why it is important in or with respect to the business. So thank you so much for watching the video. Have a nice day. Happy learning.